exciting to be here. And thank you very much for choosing this topic. There's so many interesting topics today. So today we're going to talk about our journey at customer care, building the chatbot for Wix. And we're going to start very high level just to talk about customer care because we've gone a very long way in the last few years, but still I get to speak with people around Wix and asking like, does customer care have a product? Isn't that answers? And all kind of other questions. So we're going to talk very high level about customer care, and then we're going to dive into our chatbot and our work around the chatbot until today, and finally, how LLMs are disrupting what we're building. So my name is Assaf Elovic, and I'm leading engineering at customer care. Father, I love to write about the things I learn over time, and I've been in the AI engineering space for around 8-9 years now. And with me today is Mykhailo Ulianchenko, or in short, Misha. It's just easier to say it that way, which is leading our chatbot efforts, and he will soon join the stage to talk about what we're actually building. So let's just talk very quickly about customer care. We're building a lot of various products within our company, and I think that's what's most exciting is that unlike, I think, most companies in the world, we're actually controlling the entire end-to-end flow of the user interaction with customer care. So if you look at the left, when a user at Wix has a problem or issue or something that he needs help with, it will usually start with our chatbot or help center. That's where usually that flow starts. And then in the middle, if assuming that the user did not find a problem for a solution for their problem, then we have a very, what we call the brain, a very smart set of services that kind of know how to route the user specifically the best expert in the right time. And then finally, we got our answers, which is the experts tool, which there we have our around a few thousand human experts who are helping and supporting our users daily. And I think what's most interesting about this latest disruption in generative AI is that when you look at our flow, when you look at customer care and the different areas in which users interact with us, almost in every single area in the pipeline, it's just conversation and text. So when you think about the generative AI opportunity for everything that we're doing, you can imagine that in almost every single part of the flow, we can empower both our users and our human experts with capabilities to make their life easier and more productive. So just very quickly, I want to just run through this, right? So a Wix user, I have to say hi to Shakespeare. Users start, as we said, help center, chatbot. We also have content writers who are constantly updating and writing information for help center articles. If the chatbot does not succeed, it is routed to an interaction with an expert. And as we said, in every single part of that flow, there are incredible opportunities for automation. If we zoom out from that specific flow, and we look at an entire interaction, we can also learn from interactions, sentiment, insights, issues that are happening with our products. And this is another very interesting topic that we will not touch today, but we are working today across Wix with various companies, helping them better understand user sentiment products in real time. So it's really, really fascinating. So this is very high level what we're doing at customer care. So let's speak about our current chatbot. So I don't know if you've seen this Wix, right? But when users have an issue, they usually click that right widget on the bottom right. And now it's up in the top. And this is pretty much how their conversation looks like. They come in, I have an issue. But if you look at this experience, it's not what you see when you talk with ChatGPT, right? You know, I'm sure that we're assuming that most of you have already talked with ChatGPT, at least once. And it's magical, right? You just come in, you type something, you start creating a conversation, you really feel that ChatGPT understands you and learns you. And this kind of interaction is what we see in our department as kind of like the old experience, the old ways of experiencing chatbots. And the reason why this looks this way is because without very disruptive AI understanding, you need to have buttons and kind of have more control within the conversation, which kind of limits the experience. So just a bit of numbers. We have around 1 million conversations per month with users across every single product at Wix. We are currently with our current AI, which I want to shout out for our data science group at Wix, which we're working very, very closely with. And it's just incredible partnership that we were able to get to these results. We reached 77%, meaning that we can understand almost 77% of users who come to our product, to our chatbot, and ask for a solution or report a problem. We're currently at 50% thread open rate, or in other words, around half of user interactions are resolved within the chatbot, meaning that we are able to reduce 50%, or an average 50% of interactions from reaching a human support agent, which is incredible. This is just over the last few years. We have a team working on this, product R&D of around 25 people, and we have around 15 who are writing actual content for the conversation flows, and we have around 850 flows that we have manually designed. And I want everyone here to just remember this last two. It's going to be very important for the talk. We have 15 people creating flows, and we have around 850 flows. This is today with the current chatbot. We're not yet talking about our new AI approach. So I want to talk very high level about what it is to build a chatbot in the old ways. So basically what you would do is you would take a model, like BERT or something similar, and you start to collect all the different intents or meanings, things that users usually ask when they approach the chatbot. So if you take it to a very general example, if this was a flight or a travel agent, an intent would be something like cancel booking or purchase a booking, right? This would be an intent. And then you would collect many, many ways in which users ask for that intent. You train the model. And then once a user comes in, a new user comes in, and we detect that intent, we can trigger a flow, a very deterministic flow, that is what the user converses. And then we repeat that over and over and over again as we grow and we learn more and more intents in more and more ways. So this, I mean, when you look at this, it sounds great. It almost sounds like we have a great solution, right? What else do we have to do? But this is how a flow looks like. So let's say that we have detected, using a model, that a user wants to cancel a subscription. We then trigger a flow that looks something like this. And you can just see how this flow, how many things can go wrong over time, right? Imagine if tomorrow there is a new way to cancel subscription, or imagine if there's new verticals or new products. Every single time this happens, we need someone from our design team to manually, first of all, needs to know that there was a change. And we all know at Wix that this sometimes can be very complicated. But secondly, they need to always be reactive to changes, which creates a staleness in our content. And that's very, very hard to achieve. But you might look at this and say, well, fine, well, you know, it's still worth it, right? We're saving 50% of interactions. It sounds great. So let's take an example of a bit more complex flow. So how does this look like? Easy, right? Like, I mean, it's so big, we couldn't fit it on the same screen, so we had to, like, all you can see is like little dots, right? Like, this is transferring a domain flow within our chatbot. And this is like, I'm not jealous of our content design team. This is crazy. So I think what I'm trying to convey here is that although we're doing a pretty successful job of understanding intents, helping users, and automate those flows and reducing traffic to support, it doesn't scale. It doesn't scale. The experience is very rigid, or in other words, users feel that they're talking to a robot. It doesn't feel natural. It doesn't feel like what we experience with ChatGPT. The content is stale. Oftentimes, we are too slow to react to changes at Wix, and then users who start a flow usually experience the wrong information. As we discussed, it requires content, reiterative labeling and training, and very high maintenance costs. We have a lot of people working across Wix to constantly update these flows. And this is where LLMs come in. Those new foundation models have an incredible opportunity to solve what we believe all of those challenges. Not a few, all of those challenges can be resolved using foundation models. And this is what this presentation today is about. We're going to show you how we're tackling this space. And it's also very exciting to update that just last week we actually released this new product. It's still in test, we're still on small users, but it's been a very exciting journey, so you're one of the first to actually see together with us what we actually built over time and where we are today. So this presentation assumes that everyone in this room, or at least most of you, have had some type of interaction with ChatGPT, or you've at least experienced a bit prompt engineering. So we're not going to get into an entire introduction about what are LLMs, but very generally speaking, large language models are trained to predict the best next word in a sentence, and they're very, very good at it over a wide range of topics. So most people think of large language models as models that just know how to predict words, but in the last year and a half, around 2 years, a lot of research has started to happen in this space, and where we started our journey with LLMs, we thought, imagine if AI you just provided a policy and tools, and it will know how to act. And this vision started from thinking about how do humans work. When you think about human experts, when they join Wix or almost any company in the world, basically what they do is you show them policies, you give them, like, this is how we interact, this is how we expect you to work, and then you give them a set of tools and say, well, this is your CRM, this is your good luck. And if we could get AI to work in this way, it would be incredible, right? And it turns out that there is a way to make it work. And so there's a research paper that came out around a year ago, which is called React. We're not talking about front-end React, as a previous talk that we had here. React is short for reasoning and acting. And it's an extension to a recent paper, which is called Chain of Thought. And basically, we'll go through this together. Basically, what it means is that, let's look at the left side. When a user comes in with a query or a request, the agent goes through, as you can see, an iterative process. It would do this process over and over and over again until it finally concludes that it has an answer. And this process usually goes, it's a pretty simple process. An agent has a thought based on what the user was saying. And this thought includes, do I need to use a tool, or do I have a tool that can be used to solve this problem? And if it does have a use for a tool, it would trigger that tool. It would get an output, and once it gets an output, it then decides, do I now have my answer, or should I go through this process again? And the LLM would go through this process again and again and again and again, using various tools, not just one or two, until it eventually reaches a solution. And we saw this paper, and we immediately said, well, we have to give this a try, right? And I want to give a very basic example of how this works. So let's say we have a very simple agent that its entire goal is to calculate math equations. So the way it looks like on the left is we simplified it very much, but the prompt to create this agent, it looks something like this. You prompt an instruction that says, answer the following questions as best you can. Here are the tools. You provide it with a set of actual tools that it can use. You give an example of how these tools can be used. And then when users come in and talk, it reasons and decides if a calculation is needed, for example, if a user asks about some calculation. But let's take a better example, and let's walk it through together. So who is Olivia Wilde's boyfriend? What is his current age raised to the 0.23 power? So what you see here is an actual example of an LLM. This is something that was introduced in the original papers around this subject. So basically, what you see here is the output of the actual LLM, the large language model, and how it reiterates again and again and again until it finally understands that it has the solution. So as you can see in the top right, the thought is, I need to find who is Wilde's boyfriend, right? So let's trigger a tool or an action called search. The input is Olivia Wilde boyfriend, and the output is the answer. But it's still not enough, right? All we have is the name. We still need to understand the age, and the LLM can understand that by itself, which is incredible. So then it performs another search to find the age. It finally gets the age, 29 years, but it's still not enough because now we also need to calculate the age as it was requested, and then it finally triggers a calculator action that finally performs the action, and we have the final answer, and that's where the chain is done. Yes? Sorry? No, it's an actual process. So this thought is something you request the LLM to actually generate as part of that iterative process. So it's generating those thoughts in real time and then observing itself to decide whether to continue or not. So it looks great. And if we take it to Wix as an example, so let's say if a user says, I want to connect my site to mysite.com, and we have a connect domain agent as an example, that connect domain agent can be introduced to the following tools, and then it will know how to trigger those to complete the action for the user, which again looks incredible theoretically, right? But we're ambitious, so we said, well, this sounds magical, but as you know, Wix, we're a very, very complicated company. And when we reviewed practically what this would mean to use the React approach, we're talking about hundreds, if not thousands of APIs and hundreds of different intents and topics. So unfortunately, it would be too complex for today's technology to be able to actually know how to trigger just 2 or 3 tools out of thousands. And we saw the challenges in actually succeeding with that approach. So then we asked ourselves, what if AI agents can just talk with one another, right? Let's think about it. Like, why do we need to have one huge agent with thousands of tools if we can have maybe, I don't know, hundreds of small agents with very specific, as you saw in the previous example, you have very specific agents, and then they would just talk to one another to complete a complex task. And it looks something like this. Basically, our approach is to build a multiple agent framework where we have the master agent that orchestrates or plans and executes, decides who are the right agents I need to talk with, and together with other agents, completes complex tasks. So if we just look at a very high-level example, basically we've now taken a very big complex problem, and we've created sub-agents where every sub-agent has specific roles. So for example, we have the knowledge agent, which we've just built, and the knowledge agent is connected to all our help center articles at Wix. And if someone asks questions about knowledge, the knowledge agent will know how to respond back with an answer from our articles. So the master agent, based on a user question, can decide, well, does this user have a knowledge question? Great, let's ask the knowledge agent. The knowledge agent will return a response, and he will go back to the user, ignoring all the other agents. They're not relevant for this topic. And potentially, if we can succeed in doing this well, we can create hundreds of small agents, not only for customer support, but imagine creating thousands of agents across Wix, where they all work together based on various complex tasks that users ask. And this is our approach, and now I would like now to invite Misha, who's managing this effort, leading it, innovating together with data science, to tell us all about it. Thank you.
Hi, everyone. So thank you, Assaf, for a great story. It seems like everything is done, so we can just implement new era AI assistant. We can save a lot of money for Wix. We can live new life. And I was so impressed when I heard it for the first time, maybe 4 months ago from Assaf. So I decided to implement it in one night, and I decided to start with the smallest agent. So I wrote the small prompt. I ran it a few times, and approximate accuracy that I get is how many times LLM actually stick to the instruction. They were executing our logic. It appeared to be about approximately 80%, which is okay. And up to 4 seconds depend on how many content agent need to generate as a response. So then, taking a Assaf's example, we added another agent to communicate, and the compound accuracy dropped even more. So it was 64%, which is not that great. Every third action that I wanted to perform, they were failing. By mean failing, so agent were not returning the response that I asked to return, or maybe making up some story, answering some make data. So I decided to explore it even deeper, and I added the third one, the last, and the accuracy dropped even more, 50%, which is not something that we can go to production for. So we decided to start small. We decided to implement the master agent component and to see what we can do to mitigate this hallucination, to mitigate this inaccuracy. And we made up the first business milestone, the simplest flow, as Assaf mentioned it. So we have master agent that get some user phrase. So it detects whether the answer can be answered or not, whether the question can be answered or not. If it can be answered, it's delegate the answer to the knowledge agent. And if not, it's okay. We still have an old chatbot, so we can fall back to the chatbot or to the human expert if we see that user is really frustrated, he pissed off. So the flow looks like that. Users coming to ask us about the Wix, the booking form. Agent has a thought that it's something about Wix. So I can probably try to answer it. So it picked the tool action, pick the tool knowledge agent as an action. And the input param is actually the question from the user. We pass it to the knowledge agent, get our response, and that's it. So we wrote a simple prompt that has 3 parts. First one, we profile the persona of our master agent. We are saying you're a Wix website building site to give them more context in what domain it operates. Then we added the description of the tool, when to fall back, when to go to the knowledge agent, when to the contact support. And we also describe how the schema of the response, since LLMs respond as in a plain text and we need somehow to parse it, how it looks like. So we ran it a few times. It was working really great. But then we realized that not only decision-making mechanism is something that we need in production. A legal department came to us and asked, they said, not every question that user asking you can answer. The user can ask about some internal Wix financial numbers. You cannot answer it on behalf of Wix. They can ask for financial advice. Also, it's not a good way to advise someone on behalf of Wix to buy some stocks, or try to reach us and inject some prom injection. So we added a few lines in our master agent prompt, in our initial prompt, and we moved forward. Then we realized that once we pass the user query to the master agent, to the knowledge agent, not every time the knowledge agent has an answer. Sometimes it responds with the empty row. Sometimes it actually given some text, but it's not a response for a particular user question. So we understood that we need to validate the answer from the knowledge agent to eliminate hallucination. And once we added another concern to the prompt, so once we added a few lines like, look, it might be no response, please check it, please check first, second, and third, we spot that master agents start to fail more frequent. And for production engineering, we cannot just rely on more or less. We decided to test how accurate our system is. So we took the data for the last 2 weeks. We took 400 user utterances. We manually labeled them, what result we expect the agent to return to us, what the flow should be activated, and we run the master agent against this data. So we ran it, and we got our first numbers. There was 70% of accuracy, which is really not great. Every third user would get not the best experience, would get actually the better experience. And we started to think, what can we do? We started to go over the research papers, see some YouTube videos with Indian guys saying you how to install it. As engineering minds, we found the solution in decomposition. So we decided to decompose our prompt on a few parts. We still have decision-making mechanism, which is master agent, but also we have a part that's responsible for validation. So let's put it a bit aside. Let's untie it, and we understood that we also have a guardrail that save us from the legal, not polite questions, legal concerns, or some injections. And by decomposing in a world of the agents, I mean we created a few more prompts. The first one, validation prompt. So we instruct in what cases the answer is valid, in what cases it's not. So it was quite small in compared to the biggest one that we had before. And we also created guardrail agent prompt. And we described all the concerns that we should avoid. By having these smaller prompts, we also was able to apply another concept called multi-shot prompts, where except beside the instruction to the agent, you can actually put a few more examples from your test data of how you expect the agent to behave, which actually boosts our accuracy a lot. So the schema back then was like that. We have a master agent, a guardrail agent, and then we make some operations, pass the query to the knowledge agent, and have an answer agent being activated when we have an answer. By splitting a big prompt, a big agent on a smaller one, we also got an ability to run them in parallel. So when user prompting us, like writing us some question, we can run in parallel guardrail, master agent, then we gotta get results in parallel, smaller prompts, they execute faster, and then in a code we can just manually check if it's allowed to proceed, and if we pick the tool, we gotta pick the knowledge agent. So we tested one more time the system, and our accuracy grew up to 96%, and we were able to go to production. So we got our product about 1.5 weeks ago in production, when user actually can ask us a question, can get the response, and we are really happy. But then after you launch the product, after you drinking champagne, you started to collect data and you started to review how accurate it is, how efficient, what are the business KPIs. And one thing that we spot that about 46%, almost a half of the queries that user were writing to us was either short, like bookings, payments, site indexing, whatever, or too generic, like help us with bookings. So it's impossible to give precise answer based on that type of questions. So we went to another story. We decided to disambiguate the user phrase or the user intention. Disambiguation means when you're trying to get the initial sentiment that user has. You're actually sharing with the user and trying to get as much as possible to understand what the issue is. So we started to think, what could be the best query that we might have from the user in order to answer his question at our best? And we came to the conclusion that three main parts should be in this question. First one is the scope. For us is bookings here. And then an action, what we want to perform with bookings or inside of the bookings, and where we want to perform. So having that type of question, we can really precise answer the users, give an answer to the user. So we used a concept where it's like, it's not you, but with LLMs, it's even more powerful because one of the most powerful things that LLM can do to generate the text. So we instruct our new agent that you have these three pieces. And if you think that the question, it doesn't contain one of those, please generate us the question in a way so the user will provide you more information. So the flow, when the user is coming to us and saying, I don't know, custom bookings form, agents respond, so how can I help you? Trying, to get from the user more data. Please elaborate for us what we can do. Users answer, okay, so with the custom booking forms, how can I actually add a new question to the form? And this is the all information that we need. We have a context, we have an action, we have where, so we can take the conversational history and ask master agent to generate just one question out of the few messages. And we can pass this question to the knowledge agent. So that's how we are getting even more accuracy than before. So that's something that we deployed, that's something that we are working on. Let's talk about the future. So not everyone from us will be satisfied by just response how to do it with the do-it-yourself concept. Not everyone wants to get an article and read and do it by yourself. So let's imagine that agent could get an article instead of you, another component that can read it, learn the interfaces, APIs that you have in your system, and actually execute the task for you. So user is coming to us, let's see the example, and he's saying that my HTTPS is not working. So before that, in Q&A session, we'll give him an article how to fix the HTTPS and send him back to fix it for him. So it's not the best way how to answer it. And beside that, another complexity comes here, is that user might have, so like solving this problem in an old way, we would maybe create some agent that can answer specific that question that is expert in as a subset in some specific domain in HTTPS SSL certificates. But then user may have another type of questions. They may be like thousands of questions. I don't know, like 10,000. We have in our old chatbot we have about 4,000 of intents. So you wouldn't want to create 4,000 of agents. So the concept that gonna help us here is dynamic agents. So the dynamic agents is the concept when we are taking some instruction for some particular case to solve only this problem, or it's help a user to discover some things or install the feature. It knows how to do it step by step. It also knows what API is needed to be called to help the user. Because you also don't want the user ask, to go to the various places at Wix to click all the buttons. We have all the APIs in place, so why not to ask them? Why not to use the API to actually help to troubleshoot? So, but how can we get this instruction? As I said before, it might be multiple cases on that. So we don't want to make it manually because we're gonna come back to the era of the old chatbot, where we need to make everything by hands, every flow. So let's try to generate it. At Wix, we have two big data sources. The first one is articles. Articles, they describe all the aspects of Wix life, how to install the feature, where the features are located, what the troubleshooting flow might be, what the troubles may appear. And we also have a great platformized initiative. We have well-described APIs, maybe not all of them, but majority of them. So we can actually take these two data pieces, combine them together, and ask LLM for us to create instruction on top of that, to create a step-by-step guide, not for the human being, but for the LLM, how to solve the issue. An instruction, it's something that we already did. The instruction contains condition, when to activate, when to react. It contains two types of actions. Either it's an API call, when we know that something can be done at Wix, shortly in the past, just calling the API, I don't know, canceling subscription or like buying premium, whatever, and the user action. When the action sometimes it relates to third-party back offices. When we want user come to his Facebook and then switch the toggle. So having this instruction, we already can build our first dynamic agent. So user coming to us with the problem. With disambiguation principle, we find the most relevant instruction. We instruct all the knowledge about the APIs and pass it to the dynamic agent. So the dynamic agent has the most bounded context it can have. It doesn't know about any other decision-making things about Q&A, nothing. Just the question, instruction, and set of APIs. And that gives an amazing performance, an amazing ability to perform to the agents. They stick to the instructions with a more higher rate, with more accuracy, and solve the user problem. So we started from challenges from Assaf, and it looks like we kind of covered all of them. Scale, yes, at scale, we can generate our instructions. We have really lively conversation experience because we don't tell the model what to ask or how to ask. We just say what type of information is needed. We're up to date to the content because we stick to the articles, which are updating anytime the product changed. We don't have any manual work, so it's low on maintenance. Okay, so but still, we feel that there is a risk. Every time we were saying use LLM, we actually meant use GPT. GPT is an architecture that OpenAI uses, and we actually using the model called GPT 3.5. So we rely on a single LLM provider. So anytime happens with OpenAI services, our product will not work. The second, there is a research that shows that model degrade over the time. When we add more data, it can show you worse results on generic tasks. And also you are adding more security policy for model to be polite, not to harm the user, and it also harm the accuracy and the efficiency of the model. And also hallucination and poor performance, it increased more your fine-tuning the model with human feedback fine-tuning. So the solution that we see is actually using the open source. We have plenty of models developed open source. I think that the era of the open source, at least for me, started when the Llama model was leaked into the public. So they start open source community start to develop their different models, pre-train them in a different way. So we have smaller models that can solve in a better way some particular question that can, I don't know, do math better, or they can plan and execute better, but doing overall things not that good. But you actually don't need the model to do everything. As we learned before, we can profile an agent to do some particular stuff. And with open source, of course, you can also fine-tune your model. There are various techniques how to fine-tune, how to give the model more context of your domain, of your business, and the model will execute them particularly better. So the main takeaways. First of all, if you have a complex task, if you have a big prompt, if you have some big instruction, try to decompose it. Models, they know how to do one small thing. They know how to label data. They know how to make the reasoning. But when you add in more context to your prompt, it can confuse the model. I would say the same analogy as the human brain. When the mama sends you with a list of things to buy, it's hard to remember. One thing's okay, maybe Kinder surprise, but not a lot of. The second one, anytime you have sense of that my model is great, don't trust yourself, validate. Take the data, run it through your model, really get your numbers, understand how it's gonna behave in production. And the third one is the bound context as much as possible. Don't give more information is not always better. On example, with dynamic agents work better because they only know about the problem, about the instruction, and maybe about tools that we have. Before coming to the question, I will say one more time, thank you, our amazing data science team, which make it happen. They are here, so can we give them applause? That's all I have for today. Thank you.